Good morning, good evening, good afternoon, good whatever it is, and thank you very much for joining us, and welcome to our Introduction to Python first video. So this is a part one of a two-part series where we go over some of the basic topics of Python with the intention of giving you guys a coding challenge that Sam will talk about in a few minutes. If this is your first video or you've not got Python installed on your machine or any IDE, we recommend that you watch our Getting Started video, which will be on the screen here or somewhere. But click that and that will give you a sort of how-to course made by us of how to install Python, how to install a integrated development environment of your choice, and it's really good to get started using one of those. We're going to be using PyScripter for this sort of tutorial lesson just because it's nice and simple and easy. So I'm going to hand over to Sam to tell you guys a little bit about what is coming in today's lesson.
So yeah, thank you, Luke. This video is going to cover a sort of load of different fundamental Python concepts, just to kind of get you, just to get you started really, but also to kind of create a reference guide that you can go back and look at later. And then everything that we cover will also apply later on, probably later on this week, hopefully. With a coding challenge that uses all the concepts that we've covered. In this case, we're going to be building a program that tells knock-knock jokes. But as we said, more on that later on this week. So we're going to be covering printing and how to output to the screen. Then we'll be covering stored data in Python using variables. Then Luke will be going over some arithmetic, so using Python to add numbers, subtract numbers, divide, etc. Then I'm going to be going over getting input from the user, so finding ways to actually interact with the user using the input method. And then Luke is going to be covering some libraries, so being able to use pre-existing code to kind of enhance the functionality of the program. In this case, random. So there's a built-in random library for Python that Luke is going to be covering. And then we'll be covering some data structures. So in this case, it's going to be lists. And then building on that, we're also going to be covering some dictionaries.
So we're going to be giving you guys a brief overview of all of these topics, not a comprehensive overview. We'll be publishing a video in a few weeks' time going over each one individually, which will take it in more detail, but this is a really, really good place to start. So let's get into it. Thank you very much for joining us, and I hope you enjoy. So in this part of our Introduction to Python video, we're going to be talking about outputs, what they are, why we need them, and how to do them in Python. So for a minute, imagine that you're using a calculator and you put in 2 plus 2 and you press equals and you don't get anything out. You've not received any output from that calculator, and what you've just done is basically useless, and that calculator is then useless if you can't get anything out of it. So we need to be able to give the user output when they write programs so they can see the intended purpose of the program, what's meant to happen, and what's happening along the way. So for example, if you look at my screen right now, I've got a really simple program that we take in two variables, which we'll be going over in the next part, but this is basically a way of storing data. We set a to equal 100, we set b to equal 50, and then we make c equal to a plus b. Now if I run this program here by clicking on this little green button, you'll see that it finishes and we don't get any output, because we're not telling Python to output that thing. Now imagine this is my calculator app where I want to add a and b, and I change the values of a and b each time. I want to be able to output the value of c, which is a and b added together, and the way that we do that is by using this inbuilt method into Python called the print function, and we do that really easily just by typing print followed by two brackets, and make sure that they are the rounded brackets, which you can get by pressing Shift 9 and 0 on your keyboard. Then inside of those brackets, I want to write the thing that I want to print out. And in this case, I want to print out what C is. So I'm going to press C. I'm telling Python to print out the value of C. Now when I hit run, you'll see that now it prints out 150, and we've actually got some output from our program, which is really, really cool and really, really useful. So I'm going to change the value of B. I'm going to change that 50 to 500. Then again, I'm going to hit run, and you'll see down below I'm printing the value of C, which is changed because now we're doing 100 plus 500, which equals 600, and we print out 600. So we can print out lots of different things as well. We can print out messages to the user, and the way we print out messages through these things called strings. And I'm going to get rid of all of the code here. And we're going to be going over strings in the next section, the next part as well. But that's a type of variable that allows us to store text. So for example, I'm going to print, typing in print in all lowercase, followed by 2 brackets. And then inside those brackets, I'm going to put in 2 speech marks. And then inside those speech marks, I'm going to put the sentence that I want Python to output for me. So I'm going to put in there, hello world, and make sure that you guys are able to do this at home without having any errors or anything. And do check your syntax. So make sure that your brackets are the correct brackets, and make sure that you've got speech marks here and here. So now that I've wrote that, I can hit run. And you'll see that down below in my console, just here, it's printed out hello world. So we can print out words, we can print out numbers. Let's say that I wanted to print out hello, and then I also wanted to print out my name. So I'm going to put Luke. So hello Luke. So if I hit run now, we've got 2 print statements. So the first statement is ran by Python, and it outputs hello to our terminal. And then Python looks at the next line and says, oh, it's another print function. I'm going to output Luke. And as you can see down below, it's done that, like so. Now, if I wanted to print these out in the same print function, I can do that a few ways as well. So let me get rid of this second print function. So option 1 is to just print the strings one after each other. So I'm going to do that just by putting print hello with a comma outside of the speech marks, and then put some more speech marks and write Luke, because I want to output the thing called a string which contains Luke. So I'm just going to run that again, and you'll see down below here in my output terminal that I've got hello space Luke. And Python's really nice that it does this for us, because it prints things sequentially with a space in between them when we use this comma, and that makes life really easy. So if I wanted to print and Sam like this, I could hit run, and you'll see that everything is being printed with a space in between. There is also a really easy way to do this. I could literally just write it all in one string. I could put hello Luke and Sam, and I'd get the exact same effect. But we're sort of teaching this comma because it's going to be needed for your challenge, which is coming out very, very shortly, to make a simple joke box. So there's another way that we can also join 2 strings, and we can do that by concatenating them together, and we use the plus symbol to do that. And what this does is it actually joins 2 strings and fuses them into one string. So if I hit print here, you'll see that I've got hello Luke and Sam. However, because it's actually concatenated these strings and it's joined them together, we don't get that space in between anymore. So what I'd have to do is just add a space into one of the strings. So now when it joins that string together, it has that space. So that's pretty much our brief overview of the print function and what you can do with it. Also using the plus and the comma, which we're going to be needing later for that challenge that I spoke about. So that's the end of part 1. Thank you, and I'll see you in part 2.
Hello. So now that Luke has showed you the basics of printing out some known string, we can actually build on that a little bit and learn about how we can take a piece of data within our program and then print it out to the screen. So what Luke will have showed you before is basically printing out a string. So hello world, for example. And then when you print that, you get hello world as the output. We want to work out how we can replace hello world with some variable. And a variable is essentially a piece of data within our program with a known name that we can reference throughout our program. Because obviously it's hard to keep track of data itself. So having a kind of tag on that data that we can follow throughout our code makes things a lot easier. So the way we do that is called a variable assignment. And basically what we do for a variable assignment is say our variable name, and now there are a few rules about what you can call your variable, which I'll get into in a second, but our variable name, so in this case I'll just call it name, for example, and then an assignment operator, which is basically just the equal symbol. So we're saying we want to store something in the variable name, and then our variable, so in this case I'm just going to call it Sam, and we can see much like we had with our print statement, it's in speech marks because it's a string. But this is a kind of a substitute for the speech marks here. We're actually saying the data itself that we're referencing is a string rather than we're just printing out a string. So now we can print that out very much like we did before, except rather than printing out what's in the speech marks directly, we're actually going and finding a variable first. So in this case, we want to reference our variable name. So in this case, we'd input name. So we're saying to Python, go and find whatever's in name, in this case Sam, and then print it out on the screen. So if I run this now, we can see that the variable that we print out is Sam. Now Python supports dynamic reassignment of variables, so I can change this during the running of the program. Some languages not so much, but Python is great for this. So if I said name equals Luke, and then I print that out again, and we print out name, we'll see that Python first prints out the name when it's assigned to Sam, and then it will reassign it on the next line to Luke, and then call print again. So we can see how Python runs the code line by line, going to name, going and reassigning name, and then printing it out again. So when it comes to naming our variables, there are a few things that we need to think about. And there are a few rules that we kind of need to follow. So the first one, and I've got a few examples up here, is we can actually include numbers in our variable name. However, they can't be at the start of the variable name. And this is down to how Python as a language is what's known as interpreted. And that basically means that it executes line by line as opposed to what's a compiled language. And we could probably do a video on interpretive versus compiled languages later, but I won't get into this too much. It basically means that Python is run line by line rather than compiled all at once and then executed. So when Python gets to this line, it will find a number, so it will think as it's kind of executing on the fly that it's working with a number, and then it will find a variable name that it's not previously assigned, so it will get a little bit confused about what to do, and then it will just crash. So you can include numbers in your variable name. This is absolutely fine, but you can't have a number at the start of your variable name. One of the other rules we have is we can't include spaces in our variable name, so this would throw an error. If we did want to include a space in our variable name, we could use the underscore symbol, and you get that by holding the shift key and then hitting minus, which is next to 0. And that basically allows us to have a symbol that looks like a space to space out words in our variable name. So say if we have a very long variable name, we can make it really easy to read by including spaces. One of the other great practices that we have when you have a variable name that uses multiple words is what's known as camel casing. And that's this example here. And it basically means that every new word that we have in our variable name, rather than including a space or an underscore, we capitalize the word. And that basically means that if it were just using lowercase like this, if we look at it, camel cason name, it makes it really hard to read, and you have a serious risk of anglicizing it to something totally different. So if we have capitals at the start of each word, we can clearly see that it's camel, then case, then name. So it just makes our variable names much easier to follow. Final kind of rule is there are a few kind of reserved words in Python that Python knows how to deal with when it gets it. And attempting to assign a variable to these is going to cause the program to crash. So for example, we've used print statements up until this point. If we attempted to assign a print statement to a variable, it's not going to work. There are a few other reserved symbols. So for example, your plus, your minus, your exclamation mark, they all do something in Python, so we can't use them as variable names. So that's pretty much it. As long as you kind of choose sensible variable names, you can use numbers. As long as you use that and you use camel casing when you want to have multiple different letters, or you want multiple different words, or you want to have underscores, all these are fine. And in general, there should be no real need to kind of go out your way to violate any of these kind of principles. So it's great that we now know how to print variables, but what if we actually wanted to insert our variables into a sentence? So there are a couple of ways we can do this. The first one is very simple. It's if we had, for example, hello, my name is, and then we wanted to insert our variable Luke into here, we could use the comma operator. And this basically means break out of this string and then insert a variable into it. So if I did that, and then I run it, hello, my name is Luke. It's very easy. There is also another operator that we can put in this position. We can actually use the plus symbol. But the difference is, if we run that, it doesn't automatically insert a space like it does with a comma. So if you wanted to just print out a variable really quickly and have that space put in automatically for you, this is a very straightforward way of doing that. So we could use either plus or the comma operator for this. So finally, one other way that we can actually insert data into our sentence is a little bit more complicated, but it works on very much the same principle. So what we could do is we could use the dot format method, and that basically what this means is take a string, and then at places where it knows to insert variables into, insert a variable, and then print out the string. So the way we do this is we assign our sentence. So for example, if I said A equals hello, whoops, hello, my name is. What we can do first is we can call the dot format method on it. So that's to say we have our string, perform whatever operation we specify on the string. So we can enclose it in brackets like this. So we're saying this is what we want to call the method on. Dot format, this is our dot format method. And then we can insert our variable. So this dot format method takes a number of different pieces of data and then inserts them into the string, but it won't actually know where to insert the variable. So the way we do this is we actually tell it explicitly where it's meant to put it. So in this case, we use the curly brackets, and then we give it the corresponding variable number. As we know, Python is 0 indexed, so it starts from 0. We're saying take whatever's in the first variable, in this case var, and then insert it into this string. So we're now free to print out this string. So if I go print A, then I run it, Python will go and take whatever's in var, insert it into this position, and then run the code. So if I were to create another name, name 2, whoops, disobeying the naming principles here. If I said name 2 equals Sam, what I could do is I create another variable, so and my friend, oops, I can't spell, is, and then we create another position, 1. We are free now to add another variable into here, so if I said name 2, and then run that, hello, my name is Luke, and my friend is Sam. So up until this point, we've largely just been using strings, but there are actually other different types of data that we can use. So we have our integers as well, as represented here by our int var, and this basically is our numbers. So this is going to be for the bulk of our mathematical operations. You can perform all kinds of different arithmetic on it that Luke will be just getting into in a second. It's kind of how the bulk of our mathematics is carried out, and you'll see later on that we use it in a number of different ways. So, for example, in our loops, to get the index of objects in lists, all stuff that we kind of will kind of carry on into later. But in general, having integers in your program is hugely important. Similarly, we have float, and basically a float is just any number with a decimal point. so where this would be treated as an integer, we have a decimal point in here, and it will be treated as a float. But there are a few more operations on a float that aren't included on an integer. But in general, Python will treat it in very much the same way, and you can indeed perform a division on an integer. So, for example, if I was to divide 1 by 2, I would get 0.5, and then it would be treated as a float. That's one of the kind of key differences between Python and other languages. Is Python will interpret it as a float, whereas if we were to perform an integer division on an integer, it would return an integer, and then it would actually be rounded either to would be rounded to the nearest integer. The final one I wanted to cover for the moment is booleans. Booleans are basically just true or false. So they can be 1 or 0 as well. They can kind of be... Python has this wonderful ability to kind of interpret 1 as true and 0 as false, where other languages that's the only case, but Python has a wonderful ability to do the words true and false, but also 1 and 0. An interesting little thing about Python that's not the case in other languages, true is capitalized. This is something that often trips me and Luke up, because Luke and I both have to do a lot of Java, and in Java it's not capitalized. So often we'll be programming and then it will become lowercase true, which will actually cause Python to go and look for a variable called true. It won't find it, and then it will crash.
So in part 3 we're going to take a look at arithmetic, or just maths, how we can do maths in our programming language, and there's a few ways to do it. So the first way that we can actually do it is in our Python interpreter console, and that's this thing down here. So traditionally that's where we get our output. So when we write print statements up in this part, they output down here. But we can actually run Python from this interpreter straight up, and we can run maths operations and arithmetic operations. We can also run things like print. So for example, I can write print hello down here, and it outputs it straight to the interpreter, as you can see. But there's a lot of issues with that compared. It's much harder to write code and save it as a file and then run it later, opposed to writing it up here. But we can do other things in this interpreter. So we can do 2 plus 2. You can see it's did 4. It's given me 4, which is fantastic because that's how it's supposed to work. So I can put in any numbers. I can do timesing, I can do dividing, I can do loads and loads of stuff here. But we can also do that in here where we write our proper code. And as you saw from part 1, I actually had a little bit of maths to illustrate printing out. So let's get that example back up. So I've got A equals 10 and B equals 20. Now I can do loads and loads of things here. I can do loads of maths between those two operators. So for example, I can print, not forgetting our brackets, and we can actually do mathematical operations inside that print statement, because the way that Python evaluates it is it looks inside those brackets at whatever it is meant to print out, and it joins them together, then it sends to the print function to sort out. So for example, I can do print A plus B. Now if A and B were strings that you looked at in the past part, that would concatenate these two strings together, but because Python knows that A and B are integers because it's storing a whole number, it knows that, oh okay, when I see a plus between two numbers, I add them together. So if I hit run now, we're expecting it to output 30. You can see down below we've got 30, and again we can change that plus for a times. Let me run that, and as you can see I've got 200. Now here's something interesting. If I change this to 15 and I do A divided by B, you'll see that I get 0.75, which is really, really cool. So what this has automatically done for us is do this division and converted it to a float for us already, which is something that a lot of languages don't actually do, which is really, really, really cool in Python, and it saves us a lot of time. But if you are expecting an integer, that can be something that might trip you up. So we're going to be looking at casting later on, but we can do things like cast our variables. So I want to divide A by B, and then I want to cast it to an integer, and what this does is basically says make this number an integer. So if I hit run, now see that I get 0 printed out because Python automatically rounds down its decimals to make them an integer, but that's something we'll look at in the future. But yeah, that's pretty much how you do arithmetic operations. You can do that between variables, you can do it straight between numbers in your interpreter. I mean, let's say that I want to write a program that has a number and times that by 100. So number to input is A. We store our result in B, and B will equal A times by 100. Then, down below, we can use our print statement to output stuff, print, brackets, and inside that I can put B. So if I hit run, we'll see that I've got A equals 15, B equals A times by 100, print B. Cool, that's worked down below. So that's pretty much it for the nice, simple part 3. I'll join you in the next part.
So thus far, we've exclusively been working with programs that display data to the user. Now we want to actually be able to design a program that gets input from the user and then uses that in whatever operations that it performs. So the way we can do that is we have another reserved word like print for user input, and that's literally known as the input variable. So the way we can do this is by creating a variable like we did before, using our assignment operator like we did before, but rather than print, rather than assigning a variable, we can say input. So we're saying that we want the user to define what's in this variable, and then what we would include in the brackets. So what parameters we're going to be passing our input statement. We can use a question that we want to pose to the user. So for example, input, I don't know, what is your name? And then if we print whatever's in name, we will whatever's in the variable A, we can display that to the screen. So when I run this code, it will come up with a little input window. Most interpreters will probably just have it in the command line. What is your name? And then I input Sam. If I hit OK, we can see that it's gone and taken whatever's in A, which is what the user assigned it, and then printed that out to the screen. So this is really useful for getting the user to input some kind of data into the program. But the issue with this is, regardless of what the user inputs, it's always going to be treated in the same way. That is, it's always going to be assigned as a string. So if I go and print type, so we're using this inbuilt function to find the type of a variable. And if we go and print the type of A, and then if I run this, we can see it tells us that it's of class str, which is short for string. If we wanted the user to input a number, so for example, if we wanted to get the age of a user, say, how old are you? For example, so if we said age equals input, how old are you? Regardless of what the user inputs, so if they input a number, it will still be treated as a string. So print age, print type of age. If we run that, I'm Sam and I'm 20 years old. Oops, that should be capitalized. Have another go. What is your name? Sam, and I'm 20 years old. We can see it's still treated as a string. So we want to perform what's known as a cast, which essentially means change whatever data is in this to a different type. In this case, we want to change it to an integer, so we want to treat it as a number so we can perform some kind of math on it. And the way we do this is actually very simple. We literally take whatever's in this input statement and literally change it straight into an integer. The way we do this is by encapsulating the entire input statement in this int cast, and then closing the brackets on the other side. So we're saying, whatever we find in here, change it into an integer. So if we run that now, I'm Sam, and I am 20 years old. We can see that the variable type has changed to an integer. So we can actually now perform some kind of arithmetic on that. So if I wanted to say, for example, print you will be, and then age plus 10 in 10 years time. If we run that, we can see, if I said my age is 20 now, you will be 30 in 10 years time.
Hello and welcome to part 5 of our introduction to Python. So in this little part we're going to be looking at the random library, what that is, what it does and how we can use it. So imagine that we are writing a program that simulates flipping a coin. We've got a 50-50% chance that it lands on heads or tails. How do we do that programmatically? Well, we could do it really easily. We could generate a number between 1 and 2. So we either get 1 or 2 as our random number, and we could say if it's equal to 1 it's heads, if it's equal to 2 it's equal to tails. So that's really cool and really an easy way of doing it. But how do we actually do that? Well, we can use a random number generator, and we can make use of the random library that exists inside Python to generate that random number. Now the way that we do that is by first, you can see here, importing random, and what that does is it takes the random library, which is shipped with Python, so you don't need to download anything else. It takes that random library and it gives us loads more code to actually use. So you can see here, if we look at this line, a equals random.randint 0, 5. Now this might look a little bit confusing, but don't worry because we'll go through it and we'll explain it and make sure that you have a play with it at home. So what this is basically saying is, from the random library, call the randint function, and the randint function takes two parameters, so 0 and 5, and what that tells it to do is generate a number between and including 0 and 5. So if we run that, we're going to look for our first thing, and it's generated as 1. I'm just going to run again. 0 this time, and run it again. 3 this time. So a, our variable a, which uses random.randint, generates us a number between and including these two values. So this generates us an integer. But let's say that we wanted a float, a decimal value. Well, we can use the random.random function, which I'm storing in this variable here called b, and that will generate us a decimal number between 0 and not including 1. So if I hit run, you can see down here that from the previous examples as well, it's generated a random decimal number. So again here and here, which is really cool and helpful if you need that in your program. Then finally, we've got this other method called random.randrange, and that is what we're going to be using mostly to generate our random numbers. It generates a number including 0 but up to 5. So effectively the numbers that we generate here are either going to be 0, 1, 2, 3 or 4. It doesn't include that last number. That last number is just the limit. So if we run this again and we look at the bottom value, we can see that we've got 0, we've got 1, we've got 2 here, we've got 0. You can see that on this run, a, our value that uses randint, has generated 5, which it can do because when we use .randint, it can generate that number and any number in between them. And for random range, it can generate that number, but it will go up to that number. So that's pretty much all we need for the random library for our introduction, and you can do loads and loads of really cool stuff with this. You can obviously change these numbers here, so that could be 500, and we can change these numbers here, so it doesn't have to be from 0, it could be from 1. And as you can see, there you go. If you wanted a part decimal number and whole number, so for example, let's say that I want to generate a number that's like 3 point something, or anything along those lines, I can use random.random to generate a random decimal, and I can add things to that. So let's say that I wanted this to be 3 point something random. I can do random.random plus 3, and because it's an integer plus a float, it will get us this float here of 3.9589 blah 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 blah. Let's say that we just wanted something to have one actual whole unit. We can do random.random times by 10, which will move the decimal point one place to the right. So if we run that, you can see that we've got 2.3, and this will generate us loads of random numbers. So it's really, really powerful to do here. And what we've got here is actually an example where, quite interestingly, it's generated a random number that starts with a 0. So when we've times it by 10, it's moved that decimal place one place, but it's still not a whole number. So there's a few things that we can do to combat that by literally just adding 10 or whatever. But it really comes down to your sort of implementation of what you need. So that's pretty much it for the random part, and I'll see you in part 6.
Now, we don't need to get into this too much at the moment, but one other data structure that we can use to store information is what's known as a dictionary. And basically a dictionary, kind of like how you would find it in an actual dictionary, in an actual physical dictionary, it's divided up into key and value. So in a real dictionary, it will be your word and then its description, but it basically means you have a name and then the associated data with it. How we would represent a dictionary in Python is using these curly braces. So they are on your keyboard where you would have found the square braces. And basically what we can do is we can have a string or whatever data that you can choose, as long as it's unique. There are certain rules surrounding the keys in dictionaries. They have to be unique, otherwise it would reference multiple. And then an associated value, which is separated by the colon. And that basically just means whatever is in this value has an associated key. And then we can use this to reference data by using the key. We can find whatever data is associated with it. So this example here, we are printing dictionary, and then we're using this get method, which basically is a built-in method associated with dictionaries. That means if this key exists and we pass it the parameter name key, so this key here. So if this was key 1, we would use key 1. If it exists, return the data that's associated with it. So if we run this, we can see that it returns value. So the data associated with the variable. So if I said, for example, my surname, King, and then the associated value is Sam, and then if we wanted to get the name with the associated surname King, it will return Sam. So this is all we really need to complete this week's challenge, but later on we can cover a few more dictionary operations. There are operations in which you can get all of the keys. So if I were to go print dictionary dot keys, if I run that, it will return the keys King. But in general, this is kind of all we need to complete our simple kind of joke box game.
Thank you so much for joining us. We really hope that you've enjoyed this introduction to Python lesson. We've covered a lot of the basics of Python, and we'll be going into more depth of all those topics later on. But that's pretty much this video. There'll be a part 2 to this video coming soon, where we go over a few more advanced topics. But I'm going to hand over to Sam right now to talk about our challenge that we might have referenced throughout.
Yeah, so building on what you've learned today, we've designed a challenge for you guys. There'll be a video up sometime next week, Luke.
Yep. Wednesday. Wednesday. That's what we're going to aim for.
God knows, we're so unprofessional, but it doesn't matter. Yeah, we're going to be building you guys a programming challenge that kind of builds on everything that you've learned in this lesson. We're going to make you build a game that tells knock-knock jokes. So more on that coming soon. Be sure to join our Discord to find out when we post that, and there's going to be a template that you guys can use. We'll also be posting links to that in our Discord. Luke will now edit some more links.
We'll also be going over a live coding solution as well to the problem a week after we've released it, so you guys can see our sort of thought process when we come to a problem like this, and we'll go through how we'd solve it and our sort of model solution to the problem. So Sam, you've been on working on something for a hackathon recently. Why don't you tell people what a hackathon is?
I have, yeah. So a hackathon is basically just a kind of programming challenge over the course of, most of the time it's like a weekend, a few days, but in this case it's an online hackathon and it's a week long. And I'm working on a project, so I'm going to be kind of documenting what I've been doing. It's in Python, so lots of the stuff that you've learned, I'm going to be learned in the videos that we've been making is going to be I'm going to be applying in my project. So yeah, stay tuned for that. I'm not exactly sure how I'm going to format the videos, but
We'll figure
it's
it
going to
out.
happen.
Yeah, cool. So thank you very much everyone for joining us today. We really hope that you enjoyed this. Please do leave us some comments. Please do hit that like button, subscribe, share this video with a friend. We really want to grow this community, and please do join that Discord. So thank you so much for watching, and have a great day. Bye.